Kansai Airport was constructed in 1987 at Osaka, Japan. The budget of this airport is 15 billion. The area of Kansai Airport is 530 hectares with 4,000 feet width and 2.5 miles long. The period of completion of this airport in 7 years. It uses 1 million workers and 10 million hours to finish the airport construction. Kansai Airport connects to 2 large bridges.
Kansai was built 5 kilometers from shore and contains 530 hectares of landfill, making a massive rectangle that's more than 4 kilometers long and 1,200 meters wide. That's big enough to swallow up the entire downtown area of Osaka. Connected to the mainland by the world's longest 2-tiered bridge, it's the largest public works undertaking of the 20th century, costing a total of $15 billion. With over 1 million workers putting in 10 million hours of manpower.
Of Kansai Airport. First airport that was constructed is New Tokyo International Airport. However, many of neighbors complain about this project because of noise pollution. Then, they decide to change the location of the project to sea. As other construction projects, this project also needs to face the challenge, especially when it comes to dealing with the sea. First challenge is earthquake. It is known as Tohoku earthquake. The earthquake triggered powerful tsunami wave that reached heights up to 4.5 meters. Another problem that causes is soil condition problem, which is clay soil, and last challenge is settlement
Officials wrestled with a question of sumo proportion. Exactly where do you put a new airport large enough to meet demands of the day, without the noise pollution that has spoiled many a backyard gathering? If there's no room to land planes on shore, why not have them land offshore, on another island?
The biggest challenge was to supervise the entire construction and open the airport as scheduled. There is a deposit of clay at the bottom of the sea. It's a layer of very soft clay, and if it keeps sinking after the construction, that could cause some problems for the airport.
Okay, so the bottom of Osaka Bay is made of soft, spongy clay that's likely to sink. Not really the kind of stuff you want to top off with an airport runway. If you stick an airport out in the middle of the water, how on earth do you get delivery trucks packed with peanuts and minivans loaded with luggage in and out efficiently? And dropping a little faster than planners had planned. During construction, the sand draining appeared to take care of strengthening the bay's first level of soft soil, helping to accelerate any potential sinking. By 1999, on Kansai's 5th birthday, it became apparent that the guesstimating was way off, as the entire island had already sunk over 8 meters, aging the airport 40 years ahead of schedule. As if they weren't already on shaky ground, Kansai sits in the middle of that volatile vortex of natural disasters called the Pacific Rim of Fire, home to earthquakes, tidal waves, and some of the worst weather on the planet.
The problem is collision of the soil and the water. Soil immediately under the water was a soft clay called alluvial clay. The alluvial clay went down 100 meters and Japanese engineers should solve the problem with drive down pipe that would be packed with sand. The pipe would be pulled out, leaving column of sand in place to absorb the moisture in alluvial clay. The uncertainty for the construction comes from the layer of clay laying that called the alluvial clay and extended about 1,000 feet long.
To solve the squishy problem, Kansai's engineers turned to a new sand draining technique to actually speed up the sinking by sucking the water out of the sand and shoring up the airport's foundation. But would all this talk of settling suck the life out of the project instead? Or was it already on autopilot? Too late to go back to the drawing board?
We've always had faith in our engineering, and that's been a backbone of the project.
Confident in their techniques, Kansai engineers set aside any of their own sinking feelings and moved onward and upward with a plan to beat the sinking by throwing several extra feet of fill on top for good measure. And with that, the 6-year process began. The answer came along with the construction of the Skygate Bridge. With the use of floating cranes, workers built each of the bridge's piers one at a time, cementing the pieces together like giant toy building blocks. At 3,750 meters long, it carries 6 lanes of traffic on top and 2 trains below, just high enough for boats to pass under, yet low enough for jets to fly over. To help save the structure from splitting at the seams, cracking under the pressure caused by uneven settling, engineers give a little lift to the 900 giant support columns that hold the terminal building up. It's a simple system you'll understand if you've ever changed a flat tyre before. First, each column is equipped with a sensor that's connected to a computerized system. When the island shifts, the system signals where the power lifting must take place and technicians rush in. Next, hydraulic jacks, each capable of lifting 300 tons, are inserted between the floor and the column in question. Then, the huge support is lifted and metal plates are added, one at a time, to raise the height of the upper floors back to level once again. It's a delicate game of balance that's a little like sliding a book of matches underneath a wobbly table to keep your sake from spilling. When this jacking up procedure is done, the basement floor remains at the same level, while the first floor moves up. But when you raise the roof on a 2.7 million metric ton building, things in the basement might start to look a little strange. So steps were taken to keep things on the up and up, literally. For example, double walls were installed that hang from the first floor. When the floor is jacked up, the walls follow suit. Also in the basement, air conditioning ducts are bolted to the ceiling, not the floors, keeping wires and hoses from pulling apart as the building grows. Staircases from the first floor get an extra step or 2 added to the bottom. And on the first floor, passengers are probably not even aware these metal plates at the bottom of each escalator keeps them from tripping on the trippy change in levels. And so the secret's out. The Kansai engineering team is so confident in their triumph over the ocean, they're actually at it again, building a second island with a second runway. While the city of Kobe was devastated, the advanced structural design of Kansai's terminal building stood strong, perhaps proving to Kansai critics that all those ground preparations and propping up procedures might also be enough to keep the sinking at bay.
Ground improvement work. The subsoil of immediately below the seabed surface consists of a thick, weak Holcim clay layer which should be improved so as to minimize the residual or uneven settlement after airport open its operation and to ensure the stability during the seawall construction and reclamation. Spreading of sand blanket. In the ground improvement work, first a 1.5 meter thick layer of sea sand was carefully laid and spread evenly over the seabed as a blanket. The sand blanket allowed the water discharge from Holcim clay layer to pass out and disperse the load caused by the seawall construction and reclamation. In the spreading sand blanket, 2 methods were available: to pump method and the trimmy pipe method.
Next is seawall construction work. The seawall forms the perimeter of the airport island of 13 km long, which is embankment of about 13 meter height and about 250 to 300 base width. The seawall were constructed before reclamation so as to protect the reclaimed land from wave and to prevent turbidity caused by reclamation from spreading. Next is reclamation work. While the settlement of Holcim clay layer will be complete during the reclamation work by ground improvement, Pleistocene clay layers continue to subside after the airport is opened. This large and long-term settlement was reflected in setting of thickness of reclamation land. Thank you.
First, an 11-kilometer seawall of concrete blocks outlined the shape of things to come. Think of it as building the lip around the edge of a swimming pool, only this immense enclosure keeps the water on the outside. Then, 80 barges ploughed in, dumping 180 million cubic meters of landfill inside the sea wall. That's enough to build the Great Pyramid of Giza 70 times over. Using the technology of the time, builders monitored and measured the layering of the land, making sure the fill was compacting at an even rate to prevent uneven sinking. And just as the face of the island started to pop out of the water, construction began simultaneously on two major airport landmarks. Kansai's passenger terminal proved to be an architectural conundrum that stumped even the best builders. The terminal had to be light enough to keep settling to a minimum, but what kind of fat-free materials would be strong enough to withstand Mother Nature's frequent visits, bringing typhoons and earthquakes to the area? Enter world-renowned architect Renzo Piano, the guy who gave us France's controversial Pompidou Centre. You know, that brightly coloured building with the insides on the outside. Piano proposed a design that would keep everybody at Kansai happy: engineers, builders, and pooped-out passengers at the gate. His baby? A wing-shaped terminal made of steel and reinforced glass. Exactly 1 mile long, Kansai's signature structure is one of the largest single-room buildings in the world. This aerodynamic airport opened for business on September the 4th, 1994. But because all roads don't lead to Kansai, actually just one, planners designed a myriad of mass transportation to bring both workers and passengers to the airport from all over Western Japan. It's a commuter's dream, and not a smelly cab in sight. Futuristic bullet trains like the Nankai Rapido move you in minutes to Osaka, traveling in style. Japan Railway's metro trains make several convenient stops for commuters who work at Kansai. High-speed ferries bring air travellers from Kobe across the bay. And let's not forget the luxury taxis or the over 20 limousine bus lines that serve Kansai.
It is convenient.